6 o'clock. All right. So Visual Studio in all its glory. Starting a new project. I know there's some of you that are probably using Visual Studio 2012 if you're using a lot of machines in here versus your own machine. So I'll walk you through the best I can, and if there's questions or inconsistencies, just raise your hand and I'll either come by or point you in the right direction. So just like any project, we're going to start with new project off the start screen. And you'll want to choose the web option underneath your templates. So we're looking at templates, Visual C#, and then I'm at web, and then you'll want to choose the ASP.NET web application. If you're on Visual Studio 2012, you'll see something that looks a little more like this. So it'll give you multiple project options. What you'll want to choose in this case is the ASP.NET MVC4, or if it gives you the option, MVC5 project. So for me, I'm just going to choose web. I'm going to give it the name of WSAD. This is 15FS, week 2. So that'll be the name of my project. I'll hit OK. It'll come up and then ask me more details about the type of project that I want to create. In this case, we're going to do MVC. When you select the MVC icon, it should check the MVC box below. You'll also notice on the right-hand side that you have additional user account or authentication information. Your authentication is set to individual user accounts. For now, I'm going to change that to no authentication. Hit OK. And we're not hosting in the cloud, so we don't need any Azure options. So we hit OK there. The templating system within Visual Studio goes through and scaffolds up a project for us. So as that spins, are there any questions around that, or anybody have any issues with creating their project? So just keywords to focus on, MVC. Like I said last week, there's a lot of different flavors of ASP.NET out there. What we're focusing on specifically in this course is MVC. All right, so once the project is created, let me slide this out here. It's our Solution Explorer. We get this kind of welcome page that's actually part of our project, and all it's doing is it's just providing us with information about MVC. Ways to customize the app, deployments, areas of help. A lot of these are resources that'll direct you out to the website ASP.NET. So there's actually a www.asp.net. They have all kinds of tutorials, videos, all kinds of good stuff. There's a forum out there I used to actually be pretty active on, ask a lot of questions early on. That's a good place even if you don't have questions, or let me put it this way. If you have questions but you don't feel like asking them, you can usually kind of search through there and find it. It's basically what was there before Stack Overflow existed, if you're familiar with that. So both are good resources. Typically with new projects, yeah?
When launching Visual Studio, what thing would you like to do
C#. So this tab, I usually just typically close it, and we're going to focus here on the items on the Solution Explorer for a little bit. Let me actually see if I can change my resolution. All right. So I kind of want to walk through again. I know we did a little bit last week, but I want to walk through in more detail of what's going on here with our folder structure. You know, if you think back to your Windows Form apps or your console apps, you pretty much ended up with 2 or 4 files in the project. You ended up with a whole collection of folders. So I want to kind of zoom in and focus on a particular set of folders as we kind of dive into this. Yeah. Visual Studio 2012, it comes back and asks you after you choose the MVC app, it wants to know if you want an empty app, a basic app, an internet app, web API, a bunch of options. You'll want to choose just the basic application. That should give you closest to the equivalent of what we've got. All right. So under your Solution Explorer, you get a series of folders. App data is where you will want to store your database file, your local DB, your SQL database file when we get to that point. That way it's portable, it's part of your projects when you move from computer to computer or you submit your projects to me. I will get your database file along with the rest of your project. It doesn't end up living on your local copy of SQL Server. So typically when you're running a full SQL instance, your SQL databases that you create, they live in the SQL Server under the SQL Server installation. In this case, we're going to be including them in the project and attaching them to SQL. App Start we'll touch on later. Content, that's basically where all of your static content lives. Style sheets, images, things like that live under content. The controllers is one of the big ones we're going to talk about. This is where I like to think of as the guts of your application. The controllers are the brains of your app. So when you're making a web request to a particular website or a particular URL, the controller is responsible for handling that request. And we'll dig into that in a little bit more. Fonts are fonts. That's where those live. Models is where you can create your own classes and store them inside your project. You technically can put them anywhere, but Microsoft's convention says put them under models or put them in their own class library. Keep it organized. Don't just throw classes all over the place. Scripts is where your JavaScripts live. And there's some bundling and functionality that occurs within MVC that will actually suck up your JavaScript, minify it, and then spit it out as a single compressed script instead of having all these script files that are being served up. If you remember last week, we went through and looked at a little bit of what the UC web request looks like, and there was like 50 some odd resources that were being downloaded. Well, the idea of minification is to take 50 script files, let's say, and compress them into one file. So you're not making 50 requests, you make one. And then in that process, it goes through and strips out all comments and white space from all the scripts. So it takes the file size down from whatever it used to be down to a much smaller size, eliminating all those extra characters, basically. Since your JavaScript isn't compiled, your comments and your white space come along for the ride every time that script is downloaded. ASP.NET MVC has components that actually go through and do that minification for you, so that you don't have to worry about it and gives you better performance. So scripts is where those live, and then views is the last big piece that we're going to talk about. Is you have that controller, it handles your requests, and then that HTML that you want to send back, that template is under views. So that's your actual HTML document, so to speak, that you're actually sending back to the user. All right. Any particular questions around any of that at this point? So this is the guts of the home controller. And just to give you kind of a side-by-side of what the home controller is and what it does. So home controller, and then we have three methods inside. We have an index method, an about method, and a contact method. The way that I like to think about this is that your controller name, the actual class name, is broken into two parts. The name of the controller and then the word controller. So this is our home controller. So home is the name of the controller. Okay, that makes sense. So the name of the controller is home, but it's titled as the home controller. And that name part is important because that name part ultimately becomes part of your URL, your website address. It's not part of the blah blah blah.com piece, it's the slash and what happens after the slash. Okay? So in this case we have home, becomes part of your website address as well. And that is how you navigate to a particular action. These are called actions, these methods. So you have an index action, you have an about action, and a contact action. And each one of those actions is responsible for handling a request and then returning a response. So the index action is pretty straightforward. When you make an index request, it returns the view that goes along with index. So if we jump back to the Solution Explorer, you'll see under the Views folder, we have a folder called Home. This folder contains all of the views for the home controller. Under that folder, we have 3 files: index.cshtml, about.cshtml, and contact.cshtml. Each one of those views or files correlate back to the actions, the functions, within the controller. So there's a one-to-one relationship there. So if you want to think of the method or the process you go through, it's basically you create a controller, you make an action, you write code inside of that action, and then ultimately you have to go and you have to make a view that is paired with that action. All right? And the goal is that in that function, you write some code, you collect some data, maybe you save some data to a database, you do whatever work you have to do, and then ultimately you return a view, and that view may have data bound to it, loaded into it, or that view just may be static. The goal is that you take that and you return that view as a web page back to the user. So as you get a request, maybe you get some data in, you do something with that data, and then ultimately you have to send a web page back or some type of content back to the user. And without doing that, either you're not going to get anything in or you're not going to send anything back out into the user, that the website is down or dead. So if we jump back to the browser for a sec, you'll see here that this templated website comes along with 3 menu items: Home, About, and Contact, which is in our scenario, our home controller has those same 3 actions. So if we click on About, you'll notice up in the address bar that we have localhost colon 1931, which is where our IIS Express is running. It's running on that port. Then after that, it's /home/about. So /home for the home controller, /about for the about method. So then it says here, about, and there's a header and everything, and your application description page, and use this area to provide additional information, and then we have a footer. So it's an HTML page. If I right click here and say view source, we get back HTML. If I flip back here, you'll see that we've got 2 lines of code inside of this particular action, this about action. We have viewbag.message equals your application description page, and then we have return view. Well, this little chunk of code here, this line 18, if we stop it, is compiled code, and that data gets shipped to the view. So the content that we were seeing on the page, your application description page, is actually coming from here in our C#. So if I change it, and now this is compiled code. So in Visual Studio, I had to stop debugging, make the change, and then I have to go through a build process again. So I have to rebuild my code. And since we're using the local browser, or I'm sorry, the local IIS Express, I have to relaunch Visual Studio and then refresh my page. And you'll see here that it reloads with that content. Yeah. Where's the second one come from? The second line comes from the view. So if we flip back to Visual Studio, Solution Explorer, we have this about.cs HTML. Open that up, and we see viewbag.title, viewbag.message. Use this area to provide additional information. That's where that part is coming from. It's actually statically written into the view. The part that we're pumping in is viewbag.message, I believe. Let me flip back. Yes. So viewbag.message is where that's getting pumped in. The viewbag.title right above it is actually it's a snippet of C# that's embedded right inside at the very top. So it's getting set there for the title. The message is coming from our controller, and then the rest of it is just static HTML. Now, if we wanted to, we could change this. Change this view. This view is not compiled except for at runtime. So when the page is requested for the very first time, that action is called inside of that controller, and this view needs to be returned. That all happens for the first time at runtime when that request occurs. So we can make a change here. We can hop back. We can refresh, and it recompiles on demand. So we're updating that page essentially without rebuilding the application. Does that make some sense?
But if you change viewbag.title, you have to recompile.
If I backed out title in the view,
Yeah.
up here,
Yeah.
no. Because that snippet of code is also compiled at runtime. So everything in this side of this view page gets automatically recompiled. So we can call this the about us, right? No rebuild. So you can manipulate the views just as you would any other HTML document. You can go in and edit them, change them. You can change the C# code inside of those views. Just simply save them, add a notepad or whatever your choice is, and then refresh the page, and that change will come in. If you make changes to the logic inside the controller, those changes have to be compiled. You have to rebuild them inside of Visual Studio. When you do the rebuild, we'll dig a little deeper than I wanted to, but we'll go in there. Go inside the project itself. There's a bin folder. Inside of the bin folder is where your compiled C# code goes. This compiled code ends up in a DLL file that's the same name as your project, down here at the bottom. So for us, it's WSAD FS or 15fs-week2.dll. That's the name of our project. So all of the C# code in our project is compiled into that DLL file. That DLL has to then be deployed to the server along with all of the views if you're deploying it out onto a production web server. So everything in this bin folder, not just that DLL, but really everything in the bin folder. And a lot of this stuff is the things that come along that are part of MVC. They come from NuGet. I think I talked about that briefly last week. So all of these pieces are important DLLs or class libraries that need to be shipped along with the website. All right. So let's go ahead and we'll just take a step back and make our own controller. So one of the first pieces that we'll really be talking about is the ability to go in and create a login page. It's kind of the simplest request response scenario. Put in your username, put in your password, hit login, the data goes back to the server, it does some thing, verifies it, and then either comes back and says good login or bad login, right? So we're going to create an account controller. So to do that, we'll right click on controllers. We'll choose add, and then we're going to choose the top option, which says controller. Now, what will happen through this process as well as the view process is that we're going to experience a series of, I like to call them mini wizards or guides that are going to walk us through the process. They're trying to help you get to the point of having a controller. It's not quite the same as just adding a form to a Windows form application. It's a little, they're smarter than just saying, hey, add a form, and then it spits a form out for you. So right click on the controllers folder, add controller. So you'll come up with this first screen, which should look somewhat familiar. It's going to give you what kind of controller you want. And we'll dig into most of these later. For now, we're just going to stick with the MVC5, or in your case, maybe MVC4, an empty controller is what you want. The other options have to do with getting into things like Entity Framework or Web API and being able to build out controller functionality for those. So we'll choose the empty controller at the top and hit add. And then it's finally going to ask us, what do we want to name our controller? Now you'll notice it comes up with a dialog. It puts default controller in there, and it highlights the word default. The reason for that is that your controllers must end with controller. Remember how I said there's the name of the controller and then there's the word controller? They always have to have a name and the word controller. And the reason for that is that the ASP.NET MVC, not the rendering system, but the routing system, actually uses that controller name as a convention for it to be able to identify a controller. So when you type HTTP localhost/home, it knows automatically that the controller for home is going to be called home controller. So if you don't follow that convention, putting it basically, it's ASP.NET does not like it. You get an error, it'll tell you it can't find a controller to handle that request, it doesn't work. So in this case, we're going to call this our account controller to handle our login. So we'll hit enter, it'll scaffold, and it brings us up with a brand new controller class. So this is a class, C#, it's a .cs file, just like all your other code. It's pretty straightforward. It inherits from controller. That controller class, if we mouse over it, comes from system.web.mvc.controller. That's the namespace. System.web.mvc is one of those DLLs that comes along with our project. It includes or encapsulates the logic for the MVC system. So your class, or I'm sorry, your controllers have to inherit from controller. And it's not only because ASP.NET wants you to, but it provides you with a lot of methods, functions that you can call that basically make your job easier. There are ways to override or build your own custom controllers. That's beyond the scope of this class. But there are ways to do that. There's probably a 1% case scenario where you'd really ever need to build your own controller and subsystem from the ground up. I've done cases where I've actually inherited the controller class and I've added additional properties and methods because it worked to suit my needs and my projects, but I've never built a new controller class from scratch. But you can. All right, so the second part of the template then is that you get this first method. It's your default method, index. Now, index methods or actions within all of your controllers are assumed to be the default. And again, that's customizable, that's changeable, but in this case, out of the box, it is your default action. So anytime you have an index action and you just call your home controller or call your controller by name, /account/, index is the action that then gets called. So what I'm going to do here is, instead of creating a view, I'm just going to push some content to the client, some text. So instead of returning view, and if you're curious, view is one of these classes that we get inherited from the controller class, and that includes all of the logic for actually going and fetching that view file, that CS HTML document, and then serving it up to the user. Instead of pulling up a view, which we don't have one, and I'll show you what that looks like real fast, we're just going to push some straight text content to the browser. So let me recompile and reload. So this is our home controller's index action. I'm going to go ahead and call up by going /account/ I'm going to pull up my account controller index action. So what it came back and told me, a few things. One, by just going /account, it inferred that I wanted to use the index action. So the error message tells you the view index or its master was not found, or no view engine support, supports the search location. So the view engine goes through and tries to find that web page document, that template, to serve up for index. And it tells you even where it went to look. Tilde is the root of your website. So it looked from the root of the website into the views folder, it looked for an accounts folder, and then it looked for index.aspx, index.ascx. It looked in views shared index.aspx, views shared ascx, views accounts index.cshtml, index.bbhtml, and then it went back to that shared folder again, index.cshtml and bbhtml. So in that time it took for it to try to load the page, it looked in all those places. Couldn't find a document, couldn't find a web page to serve up, and gave us this error. So that's what return view parentheses does for us. So this return line is called, that return view is going through and attempting to fetch that HTML document. So what I'm going to do instead is I want to, gotta stop debugging, is I want to return content. So we're in C#, we're just writing C# code. Return content has a series of overloads. There's 3. First one takes a string. That string is the message or content that'll actually be sent to the client. Second option is a string with a content type. So I don't know if you guys covered that previously, but you have MIME types. Have you guys heard that term before? No? A little bit? Okay. So basically every content type that you send or receive over the internet has a MIME type associated with it. Those MIME types vary depending on the content type, but some that you're probably would be most familiar with are a MIME type for images. So you have, they're strings of text. So it would say the word image/JPEG, image/GIF, image/PNG. You have application/PDF. There is application/MS-DOS, or MS Word. There's all kinds of different ones. Text/HTML, text/XML. If you go to Google MIME types, you'll come up with a whole list of them. So what it's doing is it's offering that you can send a string and then send accompanied with it a specific MIME type. And then the third option is to send content, a MIME type, and an encoding type. So we're talking about things like ASCII, Unicode, UTF-8, UTF-16. There's a lot of different other encoding types for text. 9 times out of 10, you will never use these last 2 parameters. You'll just send content if you use this method. You may find an interesting case where you could use this. Something you may not know about is you can actually take images, binary images. You can convert that binary into a text representation called base64 encoding, and then send that base64 encoded text along with the appropriate MIME type to your browser, and it will generate an image for you. And the reason that works is because that's how all of your images are actually sent whenever an image is embedded in an email. And not always, but sometimes you see it where it's actually done as an optimization inside of CSS files, style sheet files. So they'll actually base64 encode an image and embed it directly into the CSS. The easiest way that I do it is I'll delete the parenthesis, I'll type it again, it pops up, and then I just arrow down on my keyboard, and it'll rotate through them. So I'm going to do the classic hello world. I actually do one better. I'm going to put a little HTML in here. All right. So what this should render out for me is the phrase hello world, line break, VR tag, and then say this is my account controller, index action. So I'll save it. For me, I hit F6. I'll do a rebuild. Down the lower left, it says the build is successful. And then we'll go ahead and hit the play button again. That will spin back up IIS Express, recompile, get everything set up. And if you're curious why this takes so long, what's happening is that all of those DLL files are compiled not into native code, but they're compiled into what's called MSIL, or Microsoft Intermediate Language. That then gets actually interpreted by the .NET runtime and converted into native code, what you would probably think of as like C++. And the reason for that is that all those DLLs are actually portable. They can be moved from platform to platform, whether it's 32-bit, 64-bit. Now you can move them to a Mac operating system, Linux operating system, and they will run with the appropriate runtimes. It's essentially the same thing that Java does, but I have to believe that Microsoft does it a little bit better. So that's what's happening during that period of time, is that JIT compiling is happening. It's just in time JIT compiling is happening, and that's why that first load takes a little while. After that, it's very fast. So if we just refresh on here, it takes practically no time. All right, so let's navigate to the account controller. So that request to our controller spits out this HTML. If we actually right-click and view source, we'll see that literally that line of text that I put in is the only thing that was sent back to the browser. Verbatim. So what does that look like on the server side? So if we flip back to our code, I'm going to put a breakpoint right here, and right here, and right here. And I'm going to refresh this page. So the first breakpoint is hit. At this point, we've entered the method. We haven't run any actual code yet. We step into the next step. If I use my little arrows over here on the right-hand side, we've got three options. We can step into, we can step over, or we can step out. Step into gives you the ability to step into a method call. So if a method is being called from a particular line of code, you can actually kind of go a layer deeper and step into that method. So if you have a class that has a method, we might be able to step into these methods. I don't remember. We'll try it. But if you have a chain where you're branching and you're going deeper down the rabbit hole in your code, you need to call this method and see what's happening inside of it. Step into gives you the ability to step into a method and see what's actually happening and debug through that. Step over basically says run the line of code you're on and then you move on to the next line of code. So it's don't go deeper, don't go higher, just step over that line, run it, but continue on. Step out is the opposite of step in. So if maybe you went down the rabbit hole into a new function and you're walking through it, and you got to the point where you said, okay, man, that looked at the piece that I was concerned about, you can step out, which will bring you back up to the caller, the code that called that method, and let you continue on. So step in, step deeper into the code, follow the chain. Step over says call the method, I don't care what happens. Step out lets you then back up a level in your code. And we'll be using a fair bit of that as we debug, and I want you guys to get some good practice with it. So I'm going to go ahead and step over this curly bracket because it doesn't do anything. If I tried to step into the curly bracket, it would still just step over it because it doesn't do anything. So now on this method of content, return content with our HTML inside. So the first thing that happens is the content method is called, passing in our text. It does some work, and then ultimately whatever comes out of that content method is what's returned. So we'll go ahead and we'll try to step into this. Okay. Since this is compiled code with no debug symbols, we can't step into it. We don't have source code to step into. So Visual Studio identified that and just went ahead and stepped over. If we had our own method, we could step into that method and debug through it. And I can show you that if you have an interest. So this line of code runs. The object gets returned. The last step in the method is obviously to exit the method. And at that point, we get our new content of our page. Now let me show you this a little differently. So I'm going to navigate to a different page. I just want you to kind of get a sense of what's happening here. I'm going to now navigate, not using my back button, but actually going to it for the first time. Do you guys know that there's a difference between typing in a URL and hitting enter versus just hitting the back button to go to a page?
You go back and use the cached version, right?
Correct. Typically, if you use your back button in your browser, it will just pull it from cache. It will not go back to the server and request it. Do you guys understand what the cache is? It's where the browser takes those files and downloads and keeps them locally. So hitting enter again, I'm going to rebuild that request. So it jumps me back to my code. Flipping back to the page is waiting for a response. I'm still on that old page. If I step over here, I'm still waiting. Nothing has changed here. If I step over again, nothing has changed here. Because while that return occurred, that return is not the final step in the process of rendering out this content. It's simply the piece that does the logic. There's still the packaging, there's still building the HTTP response header, there's a lot of pieces, a lot of magic, if we want to use that term, that has to go into allowing this page to ultimately be rendered out. So not until this method finishes completely do we end up with page. Okay? So even though we're just sending this little bit of code, I'm going to reload it again here. So this is the response text that we sent. This response header here is all of the work that ASP.NET MVC is doing for us. Sending an HTTP 1.1 200 OK response, cache control is private, content type is those MIME types, text/HTML with a character set of UTF-8, so our text is UTF-8 encoded. The content is gzip compressed, so it takes that text and actually runs a zip compression on it before it ships it to the browser. The browser then turns around and actually unzips it before it shows it to us, because it has to unzip it in order to read the content. This very accepting coding, that's actually telling the browser what kind of encoding the server will accept. The server actually tells the browser what kind of server it is, says that it's running ASP.NET MVC version 5.2, ASP.NET version 4.0. I'm not sure what that line of string is, but there's something in there. We'll look that up. Tells it's powered by ASP.NET, gives the current date and time for the server, and then invites it gives you the content line. So all of that gets computed and set up as part of the response. Are there any questions around those pieces? Not to be shy All right, so at this point, we could go through and we could type all of our HTML into these actions. Obviously, we haven't done anything amazing, but we could go through and hand code all the HTML. We could come in here and do, let me stop my debug. We can come in here and do HTML, body, h1, p tag, right? Same stuff you would typically write in an HTML document. So if we compile this and run it, I have to give my virtual machine some more CPU. We get back to this page with the HTML that we built. So you can do that. There's nothing wrong with doing that. You're saving it from going out and fetching that view and doing all that extra work, but it's not the most effective way to do web design. Right? You have good designers, you have good tools that help you do that, so doing it this way doesn't make sense. So instead, you take all of this and you put it in a view. So to build a view for this action, you have to go inside of your Solution Explorer. You go down to the Views folder. Oh, hey, look, there's an account folder now. Part of creating that controller, Visual Studio goes ahead and actually creates an account folder for you as well. So we can right-click here under Account and say Add View. It'll come up, it'll ask you what you want to name the view, what kind of template do you want to use for the view, do you want to use a layout page for the view, all kinds of stuff. You want to create a partial view or a full view, we'll get into what partial views are later, all kinds of options. Now the trick here is that you have to make sure that you call this index, because that name has to match the name of your action. So this is our index view for our account controller that goes with our index action. We're going to say it's an empty template without any models and click Add. And it'll go through and scaffold up a page. It's nothing fancy, but you can then go in and write your HTML here. So I can take my HTML that I wrote, paste it in here, hit save. Come back and run. Should really learn to keep this up instead of stopping it every time. Notice that it navigated me to account/index instead of taking me to the root of the site. It knew that because I was currently editing that view. It inferred it from the view that I was sitting on. I'm not totally sure what this is going to render out as. Now, if we look at the source code for this, you'll see something interesting. You see here is the HTML. There's this head tag. There's a body tag. There's all of this stuff here that makes up the navigation. Scroll down further, here's my little snippet of code that I actually put in. There's another HTML and another body tag. And there's this HR and a footer and scripts and all kinds of stuff. Just as a side note here, you'll notice it says scripts bundle / jQuery and the string. That's the bundle for all the jQuery stuff that's been minified. Puts it in a single bundle. So we'll talk about that more later. But here's our HTML. So where did all this other code come from? Well, within ASP.NET MVC, you have the ability to create what are called layouts. Those layouts, you can think of them as page templates. So you want your page to maybe have your, or rather I should say, your page should follow along with the rest of your site layout. Your site has a design. Your site has a layout, right? One of the first things you do when you design a website is you probably don't actually jump in and do some HTML. You probably jump into Photoshop or something and you start looking at, where do I want to put the navigation? Where do I want to put the header? Do I have a logo that I need to incorporate? What does the content of the page look like? What kind of layout components do I need to put on that page? Well, you do all of that, and then you add content. So that layout is consistent across the entire website. So the need to copy and paste that code and inject it into every page seems a little redundant. So what you do instead is you create a layout one time and you designate spaces within the page where the content needs to be injected. So underneath your views is a folder called shared. Underneath there is an underscore layout.cs HTML. And inside of that is where all that other HTML markup comes from. So if you want to customize the layout of your site, you go here. You make the change once, and it updates all of your web pages. And that means that then within your views, you don't have to include all of this. You just include the content that's needed for the view. That's why the only piece of content that actually came out on the page was the H1 tag and the P tag that I put in there. Because all of this took care of the header and everything else. And the browser was smart enough to ignore the duplicates. So here's the nav bar for the top nav. There's some bundles for style sheets and other pieces. Here's the title tag that lives up in the head. Our doc type is up at the top there. And as we scroll down, we'll see here's this div that's the body content. It's got a class, body content. And then there's this method called render body. That method is a piece of code that tells ASP.NET to take the view that's being served up and to render it there in the page. Not at the bottom, not at the top, but right in between those two div tags. That's where your content goes and gets rendered. Is where this render body call happens. We have a footer and some scripts. We also have this area here that says render section for scripts. You can actually identify sections or regions within your layout where specific code needs to go or be rendered. And then that code can then be part of your view. So let's say you have a website that's a 2-column layout. Well, column 1 needs to have a piece of content X, and column 2 should have content Y. Well, both content X and content Y can be inside of your view. They just get rendered in different sections of the page. So I just wanted to give you an understanding of how these pieces work. So you have your layout, which is shared. It's in that shared folder. That then gets sucked up as part of the output that gets rendered. The view that you create then gets pulled in and injected where we call render body, and then all of that together gets pushed back to the browser, along with the scripts and anything else that needs to come along for the ride. So because of that, we can strip out most of this. So if I strip that out, go back to my browser, close that, refresh this, the page will actually come back rendered the same way. We look at the view source, we'll see that we just have the H1 and the P tag now because we pulled out the rest. Any questions around any of that? One last thing I want to show you is a little bit more of that view bag. We saw it when we were looking at some of the defaults that come along for a ride. So if we jump back underneath views and shared and we look at that layout. You'll see here that we have a title tag, typical. You'll see that in between these title tag elements, we have this @ viewbag.title. That @ symbol, and we'll really talk about this next week, but I want to give you something to kind of carry. The @ symbol is called the Razor syntax identifier. I forget the actual term they use, but it's basically the token that's used by the view engine to know whether what's being pushed out is HTML or if it's C# that needs to be evaluated and compiled. In this case, @viewbag.title says go to the view bag and grab the title from the view bag. And then after that, you come back to HTML where you have -- my ASP.NET application. Now that viewbag.title is not coming from the controller. It's actually coming from our view. Up here in this little snippet of C# is where that's getting set. So it's getting set here, but then it ultimately gets rendered out by the layout. So that's a line of C# that's getting evaluated. This code gets injected into the layout view, and then the layout gets compiled. And that little snippet of code gets compiled along for the ride, and then that viewbag.title gets replaced on the layout with the actual string of text that we have in here. And the same goes for all of your bindings. You basically are putting what I kind of like to think of as tokens of content that you need dropped into your page. You're identifying a variable in your view, and then at runtime it gets compiled, and then those strings that you maybe passed in all get rendered out into the web page itself. So think of it like a fancy find and replace. So that can happen here, or it can happen in the action. You can define those view bag properties. And if you're curious about how these names are coming up, the view bag is a variable, it's a property that's part of the controller. And it's actually part of the view. The view itself actually is a class under the hood. So you're dealing with the HTML side. The viewbag property is referred to as a dynamic. So if you're not familiar with that, again, we'll talk more about it next week. But if you want to search for .NET dynamic type or C# dynamic type, it's basically a type that allows you to freely do whatever property you want, and it just creates it. It's kind of like a dictionary with key value pairs, but instead of using the square bracket quotes for the key and then the value being injected, it does the dot notation. It's actually kind of a fun little thing. That tripped me up when I was first learning in VC. I couldn't quite understand what they were doing, and then finally I researched the dynamic in more detail, and I went, oh, that makes total sense how they're doing it. That's a really clever way to do it. But that might be something I'll probably ask you, I'll send you an article for this week just to read and kind of get up to speed on what the dynamic is. It's kind of a weird concept. You don't see it in that many languages. So at least having a bit of an understanding, it helps. You see it probably in JavaScript more than anywhere else, but JavaScript's an interpreted language, and it's pretty dynamic anyway. You have no data type, so it kind of lets you do whatever you want. So, all right. All right, so I think that will be it for this week.